So an envelope generator is what we would call a modulation source, a variable voltage signal that can be used to modulate various things in a synthesizer. There are many other modulation sources in a modular system that offers different kinds of controls and shapes. We learned that the maths allows us to set rise and fall times to create custom envelopes. A couple of other very common modulation sources is an LFO, or a low-frequency oscillator, and something called a sample and hold. And both of these functions are available in our system through the System80 850 utility module. An LFO, or a low-frequency oscillator, is simply an oscillator that runs very, very slow, below audio rate. So not at a frequency where we can perceive as audible pitches. So everything we know about an oscillator still applies to the LFO in terms of it outputting repeating waveforms and having those waveforms run at a steady rate set by a frequency or a rate control. So on the 850, here is our LFO section. It has a frequency control, and it even has a light that indicates how fast the waveform is oscillating at. Now, one very common use for an LFO is creating vibrato for an oscillator. And usually there are additional control inputs for the oscillator pitch that we can use for a vibrato effect. So here, we're taking the output of the LFO and sending it to our modulation input of our oscillator. And this input has something attached to it called an attenuator knob, which is a very, very important utility in synthesis in modular. And basically it helps control how much of an incoming signal is affecting the target parameter. In our case, we are targeting the pitch of the oscillator. Now, if we remember that in Eurorack format, a 1 volt change equals a 1 octave change. A low frequency oscillator, an LFO, that's sweeping between, say, 0 volts and 5 volts, if we simply plug that into an unattenuated pitch modulation input, it's going to sweep through 5 octaves of frequency of our oscillator, which is not typically a very musical effect. So to create a gentle vibrato, we therefore need to limit the range of the incoming LFO. And luckily on this particular oscillator, there is an attenuated input for modulating the frequency. So if I turn up my oscillator right now, we are not hearing any change because the modulation amount is at 0. Now, if I turn this up, we are now hearing our low frequency oscillator modulating the pitch of our oscillator. If I turn the modulation amount up, it's going to sweep through a larger range of the oscillator frequencies range. Another use for an LFO is to create a tremolo effect by using it to control the volume of a VCA instead of controlling the pitch of an oscillator. So here, I'm going to take this out of the oscillator, and instead of controlling the pitch of the oscillator, I'm going to take it to control the voltage of my VCA. Now if I turn this up, there's no change because the VCA also has an attenuator for the control voltage input, and right now it's all the way down. So if I turn this up, now my LFO, the triangle waveform, is now controlling the level of my VCA, creating a tremolo effect. On this particular LFO, there's also a range switch. So right now it's at the lower range. If I sweep it up to the higher range of the LFO, I can make the LFO run a bit faster, create a bit of a different effect. A sample and hold is a device that consists of a clock signal and an input source to be sampled. How it works is that at every clock signal, the sample and hold freezes or samples whatever voltage level is at the input and holds that voltage until the next clock signal. So in other words, based on the rate of the sample and hold clock, it creates a stepped voltage output. And we can demonstrate this quite clearly using an LFO as our input source. Now, in our 850 module, next to the LFO is our sample and hold circuit. And the sample and hold circuit here gives us a few different choices for what the input source is. So we've got white noise, we've got a sine wave, a built-in sine wave in this one, a sawtooth, and an external input or the LFO next to it as the input source. And so we're going to select the LFO, this LFO, as the input source for the sample and hold. So this means that this waveform, it's going into the sample and hold. And at every clock input, it's going to capture and hold whatever voltage that LFO is providing to the sample and hold. So what happens is, for our first oscillator, we have the LFO going straight to the modular, to the modulation input. For the sample and hold output, we're taking that into our second oscillator's pitch modulation input. And if we listen to both at the same time, you can compare the smooth LFO and then what the sample and hold does to the LFO. So it holds the voltage that the LFO is providing at every clock, creating a step voltage. If I slow down the sample and hold clock, it gives me a slower step. If I increase the rate of the LFO, the value between each step becomes a bit bigger because the LFO is running a bit faster. So the voltage is changing faster. If I slow down the LFO, the stepwise motion is slower. And you can still hear the original LFO. Now we said that we can use any input source for a sample and hold. Another very common usage of this sample and hold is by feeding it a noise source. So instead of taking the LFO from the module itself, we're going to switch this input source as noise. And what noise is, it provides a sample and hold with all kinds of random full range of frequencies at any given point. And what happens with noise being fed into a sample and hold is that then it creates a random stepped voltage. Here with our sample and hold circuit and having this built-in noise as an input source and then feeding it into our second oscillator, we get a random step sequence.